Hello. So in the last video we set up the player's body rotation, so now we have full control over our player. Now we just need to set up the animation tree to make use of the walk and run animations, punch animations, and the hand poses for hand tracking. So here I am in Godot, in our player scene. I'll start by adding an animation tree node to our scene. For the animation tree root, I'll choose an animation node blend tree. The one you choose will depend on how you're setting up your animation tree, and as we set up ours, it'll become clear as to why we chose this one as our root. Then we'll choose our animation player, and then we click on Active On so that we can see the output of the animation tree in the editor. So now we can begin creating the animation tree here. First, I'll set up the walk and run animations. I'll add a one-dimensional blend space and open up its editor. Then in the center at 0, I'll add this idle legs animation I made, which is just a pose of the legs standing still. Then at 1, the maximum value of the blend space, I'll add the run animation. Then at, let's say, 0.2, I'll add the walk animation. This way, if you're using a joystick to control the player, smaller inputs will use the walk speed. Or if you wanted, you can make it so at full walk speed, the blend value for this blend space can be wherever you put the walk animation, for me at 0.2, and then it changes to 1 if the player presses a sprint button. These are just some ideas on how you can completely customize your player controller. Then what I'll also do is add the run animation at -1 and select play mode backward. And the same for the walk animation. And this will make it so that if the player is moving backward, the run and walk animations will play in reverse. Nice. Now I'll go back to the tree root and play around with this blend value to test the animations. Oops, I forgot to set the animations to loop. All we have to do is click on the animation player and select each animation we want to loop and click this little loop symbol here for all of them. Okay, and now we can see that the walk blend space is working correctly. But right here you can see at -0.5, the walk and run animations are out of step with each other. Well, I forgot to say that when I was making the walk and run animations, I thought ahead to this point and decided to make the walk and run animations the exact same speed, so that I could programmatically adjust the speed of the walk and run blend tree according to the actual movement speed of the player. I did that in Blender a while ago, so this time I can be sure that the problem here is that these animations are out of sync, because I need to go into the blend space editor here and press sync. You will want to do this for any animations that you're blending together that need to be synced with each other like this. Alright, now you can see that it works correctly. Then, so that I can adjust this playback speed with code, I'll add a time scale node in front of this. Now for the hand tracking, I'm going to want to add a two-dimensional blend space. I'm going to be using the camera's rotation as the blend value here later. In the center, I'll add the centered idle animation, and I'll add all 8 animations for each direction. Now that those are set up, we can test it out. And everything looks great. I'll also add a timescale node to this blend space as well, just in case I want to adjust the idle animation speed. So now we need a way to mix these two blend spaces together. Right now, each blend space takes full control of the entire armature, so what we can do is add a blend to node, which blends the two inputs together. Then we go down to edit filters, check enable filtering, and then filter out all the upper body bone animations for the first input, which is the leg animations. Now we can see that it all works together. Lastly, I'm going to set up my punch animations. Since these will only be triggered once at a time each time the player presses the attack button, I'll use the one-shot node. Since my player controller will have separate punch animations for the left and right arms, I'll add 2 one-shot nodes, one for each hand. Then for each hand, I'll add a blend space 1D. This blend space will be used to switch between the jab punch animation and the hook punch animation by just changing the blend value from 0 to 1. This way, if you had more than 2 punch animations, you can just add them to this blend space. Then I'll go into this editor. I'm going to set this increment value to 1, just so there are no floating point values allowed between 0 and 1. And I'll set the minimum value to 0 and my max to 1. I'm going to put my jab animations at 0 and my hook animations at 1. But since I have a down, forward, and up animation for each punch, I'll add another one-dimensional blend space for the jabs and another for the hooks. Make sure that you name all your nodes well because you will be accessing them in code. In the jab blend space, I'll put the down animation at -1, forward at 0, up at 1. Then I'll do the same for the hook animations. And again for the left arm punches. Now if we test fire the one-shots, we can see that again we need to enable filtering for these. When these punch animations trigger, we want to ignore the arm animations for hand tracking so that the one-shot animation can control them. I'm also going to add some timescale nodes to these so that I can control the punch speed programmatically as well. So now our animation tree is set up. Now we need to add the code to our player controller that allows us to control the blend values for the animation tree. So first, real quick, I want to fix a mistake I made in the last video. I noticed that my player's body wouldn't always align with the camera when moving and would kind of lock up like this. This is because in the handle body rotation function, I wrote LIF velocity and then rotate the body, which means that if these other LIF blocks up here are being called, this block won't be called at all. The proper solution is to change LIF to IF. That way, regardless of any of those other conditions, the body will rotate if there is velocity. Before I start setting up the animation controls, I need to add attack input handling to the controller. First, I need to go into the input map again in the project settings because I forgot to make an attack action. Up here with the global variables, I store the attack input in attack pressed. I've added a function call to the input function down here named handle attack input. And then down here I've defined this function. By default always, attack pressed will be false, unless of course the attack button is pressed, then it will become true until it is not being pressed anymore. Now to set up the animation controls, I'll add a node reference to the animation tree up here with my global variables. Then I'll add these two global variables to store the blend value for the hand tracking and the speed of the run animation. After that, I have a bunch of global variables that are used for triggering the attacks. Before I explain these, this is how my punches are going to work. For my game, I want to be able to hold down the punch button constantly, and I want it to alternate from right hand to left. Each time the punch is triggered, it randomly chooses a jab or a hook animation. So next attack hand tells us which hand to attack with next. Left and right hand attack ready tells us if the left or right hand is allowed to trigger a punch or not. Is right or left hand attacking tells us if the hand is currently in a punch animation or not. Is attacking will tell us if any hand is attacking at all. All of these are set to false except right hand attack ready because I'm a righty, so I'm making it so my character starts with the right hand. Down here in physics process, I've added two function calls named handle animations and handle attacks. I've separated the two because in the future, handle attacks function will contain more combat logic. I also placed the handle attacks function before the handle body rotation function because the handle attacks function will affect the body's rotation. Handle animations goes at the end of all the calculations that can occur, and the model will be animated at the end. Here we define the handle animations function. First we get the camera's pitch rotation like this. Then we want to find the camera's yaw rotation relative to the body's rotation. We do this with the same method as in the last video by taking the dot product of the body's basis.x and the camera's basis.z. But in the last video, I got the arc cosine of this value. I'm not doing it here because with just the dot product, this value will be 0 when the camera is centered, negative when facing left, and positive when facing right. This is all we need because down here we remap these values for the animation blend spaces. Then here, I'm going to remap the camera's pitch rotation to be within the values -1 and 1. Then I remap the relative rotation value to be within -0.9 and 0.9. I know from a calculator that since my head can only rotate a maximum of 35 degrees from the body, the dot product we calculated will only return a minimum of negative 0.59 and positive 0.59. I did 0.9 instead of 1 because letting the arm poses reach their extremes kind of looked jarring when testing it out, so this gives it a little cushion. Then we use the camera's pitch rotation and relative body rotation and store them in a vector 2 that represents the blend value to be passed to the animation tree. I used the lerp function with a factor of 20 times delta to make the movement smooth but also kind of snappy. Then, if the player's velocity is not 0, then we remap the player's velocity to be within 1 and 1.25 in this animation run speed value, which will be applied to the move animation timescale node, and then otherwise the animation run speed is set to 0. Then, our last step is to set all the animation tree blend values. You can figure out the path to each of the blend parameters by clicking on the animation tree and clicking the drop down for parameters. Go to the parameter you want and right click and click copy property path. We set the look blend value to the animation hands target vector that we made earlier. We set the move blend value to the player's velocity, normalize, and then we get the magnitude of this vector as a float with dot length. I'm also going to reuse the Y component of the animation hands target vector to drive the up, forward, or down blend spaces for the punch animations. Finally, in this handle attacks function, first we want to see if the attack button is pressed, then that the next hand is R, and then that the right hand is ready to attack. If these conditions are met, then we generate a 0 or 1 randomly with rand I with the modulo symbol and 2. Then we set the blend space for switching between jab or hook to this random number. If it's 0, it will do a jab, if 1, a hook. Then we're going to set the kind of one-shot request we want to trigger, which is fire as opposed to abort. And then we set the one-shot to active to trigger the attack. Then elif, we do the same for the left hand. Lastly, is attacking is set to is right hand attacking or is left hand attacking. Now let's go ahead and start the game and try everything out. Awesome. Now the hand tracking works and you can see the walk animation right here. And if I try to punch, nice. If I try to punch again, oops. In the handle attacks function, when a punch is triggered, we set the left hand attack ready variable to false and is right hand attacking to true, but it never gets set back so that we can trigger the next punch. To do this, I'll create some animation events to toggle these values at a certain point in the punch animation. When these events are triggered, we will call one of these two functions, where if toggle right hand attack ready is called, right hand attack ready is set to true, and is left hand attacking is set to false, and vice versa. Now to add these animation events to our animations, click on the animation player and go to the first punch animation, click on add track and select call method track because we want to call a method when this event is triggered. Then click on the node that has the script with those functions we defined on them. This will add this track down here. Now, so I can see this animation from the animation player, I have to turn off the animation tree, click on that and disable active. Now I'll scrub to the point in the punch animation where I want the other hand's punch to be ready, somewhere right after the impact of the punch. And I'll right click to insert key, and it will let me select the method I want to call. Since this animation is for the left hand, we will want to call the toggle right hand attack ready function. Now do this for all the punch animations. Oh, and I forgot one more thing. I want the body to rotate towards the camera when punching, so I have to go up here and put this block of code right here. If we're attacking, align the body to the camera with slurp. And change if velocity to elif because now we want it to do it only if it's not punching. Alright, now when we start the game, the punches should work as we described. Okay, clearly I did something wrong because it doesn't look like those event methods are being called. Turns out, if I go back to my animation tree, I need to go back over to the Edit Filters menu on the one-shots, and I need to enable filtering for these new tracks we made. with the call method events. Now let's try running the game. There we go. So now we have a player controller with punch animations and basic movement controls. At this point, I would want to start working on my combat system for the controller. So this is where this series is going to branch off a little bit, because the combat for your games will probably vary a lot more than the player movement mechanics. So instead, I'll continue to create videos like this on how to create all these systems, but they will be specifically in the context of the game I'm creating, which is a first-person zombie survival game. So my hope is that while watching my design process for all of these things, you'll take away a lot of knowledge on new concepts and how to manage a large project as a solo dev. So keep an eye out for my next series that will go over a basic enemy AI system for our zombies in our game. Thanks for watching.